Okay, this is section 6.5. We're going to split this up into at least 2 days of notes, maybe 3. This is on operations with radical expressions. You did a little bit probably with adding and subtracting radicals in maybe Algebra 1, but we're going to go through what they call the product property and the quotient property and simplifying radicals. So first the author talks about the product property. You have actually already used it before in Algebra 1. If I said radical 2 times radical 2 is radical 4, square root of 4 is 2. So radical 2 times radical 2 is 2. So you've actually used this property before. Okay, but now we're going to get into it a little bit deeper than that. Okay, first, if n is even and A and B are non-negative, then the nth root of AB, basically you can split that up into the nth root of A times the nth root of B. Now look at that again. They're saying if n is even, so n could be 2, 4, 6, 8. If the index is even and A and B are non-negative, then you can split them up or you can put them back together. Okay? So if I had the square root of 2 times the square root of 8, okay, this property says it's okay then, both the n's is square root, so the n is even, the 2 and the 8 are non-negative, so therefore I can put them back together, multiply the numbers inside, and then say the square root of 16 is 4. And my final answer would be 4. And this property can be pretty handy.
So if you do that, even if you have like 2 is your index and 4 is your index? Like if the index is different,
they have to be the same. Because look at your formula. These have to be the same. They're both ends. Yeah. Yep.
Nope.
No. You might possibly be able to simplify the fourth root down into a square root of something, and that's possible. Okay. Okay. Now, if the other part of this is if n is odd, then if n is odd, then the nth root of AB equals the nth root of A times the nth root of B. So example, let's do a cube root. So if I said the cube root of 3 times the cube root of 9, okay, then by this property, is there any restrictions on the positive or negative inside? Not on this. Okay, because it's okay to have a cube root of a negative number. Okay, so on this you'd have the cube root. You could put those together. Say it's the cube root of 27. And the cube root of 27 is 3. Final answer would be 3. Okay. So on this product property, if another example, let's say I did the square root of -2 times the square root of -8, and that would be the square root of 16, which would be 4. Everybody okay with that? Oh, wake up. Yes. -2, is that non-negative? No. This is where the author's going to catch you, sleeping. on a test or on your homework. Okay, this is not legal. Okay, what is the square root of a -2? Now you can take that, you can take out of that you can take out an I. This one you can take out an I, you could take out a 2i, still have a radical 2 left. I times I squared, so we'd have 2i squared. Radical 2 times radical 2 is 2, so you'd have 4i squared. I squared is -1. Final answer is -4. So, on this part of the notes, you need to highlight, star this word, non-negative. Okay? If they're doing an even root with a negative number, you cannot just multiply them together. That will not work. Okay? Okay. Caught some of you sleeping. Okay. Quotient property. Okay, the quotient property says for any real numbers A and B, B can't be 0, N is greater than 1. Now the quotient property says the nth root of A divided by B. That's all underneath that radical. Okay, as long as A and B are real numbers. Okay, so you're not going to have any imaginaries. Okay, then it's legal to split this up into the nth root of A over the nth root of B. Okay, and B, remember, can't be 0. Example. If I had, does it say anything about even or odd? No. So, example, if I have the cube root of 54 divided by the cube root of 2, as long as those indexes are the same, okay, and we don't have any imaginaries, then it's legal to put it back together. We could have the cube root of 54 divided by 2. 54 divided by 2? 27. Cube root of 27 would be 3. Okay. So that quotient property works for even and odd indexes. You just have to remember the denominator cannot be 0. Okay. You can. This property allows you to put them back together or to separate them. Okay. Okay. Then the author goes through when is a radical expression simplified. There's 4 parts to this. Radical expression is simplified when all the conditions are met. A radical expression is simplified when all the conditions are met. And there are 4 of them. First one, the index is as small as possible. And really, at this point, we haven't done anything to simplify indexes yet, so I don't think you're going to have any problems with that one. The second one, the radicand, that is the part underneath the radical. The radicand The radicand contains no factors other than 1 that are the nth powers of an integer or polynomial. So basically what they're saying there is you can't leave something inside the radicand that you should have taken outside. Okay? The third part, the radicand contains no fractions. You can't have a fraction underneath a radical. Fourth step, no radicals appear in the denominator. Cannot have a radical in the denominator. Okay. Now I'm going to go through several examples, trying to point out some of these as we go through, and part of it just to show you the method that you use to simplify these. Okay. So on the directions it'll just say simplify, or solve, or evaluate, simplify. This first one's similar to what we did on the test. The square root of 25, a to the 4th, b to the 9th. And it's a square root. You always want to look at that index and split it up. Now, some of you may be at that point where you don't have to write it out this long way. And if you feel like you're at that point, I'm okay with that. But if not, write it out. Okay, so I would end up saying, okay, I'm looking for squares inside there. So a to the 4th I can split up into a squared times a squared. B to the 9th I could split up into b squared, b squared, b squared. That'd be b to the 6th, b to the 8th, b to the 9th. Okay, and then circle what can I take out? Square root of 25. 5. Out of this I can take out an a, and an a would be a squared. So really, when you're taking them out, you're actually multiplying them. Out of this you could take a b, 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 so b to the 4th, and I still have a square root of b left. Now, some of you may be able to look at this and say, okay, I know the square root of 25, I need a 5. Yeah, so if I take out a, it's actually a squared inside squared. So I could take out an a squared. Okay, and it's actually b squared to the 4th times a b. So I could take out, no, I need it the other way. Sorry, I need that the other way. So I could take out a b to the 4th, and radical b left. If you can see it from that answer to that, then I say do it that way. Otherwise, I would write it out the long way. Okay? Everybody good with that? That'll work. Yep, as long as it works. Yep. Okay, now let's use the product property and quotient property a little bit. Okay, another example. Let's say they give you the square root, and when you do these, write your radical big enough and draw it all the way down. This is y to the 8th on top over x to the 7th on the bottom. Now, what controls this, look up here for a minute, is you're looking at this index, it's a square, and you have an x to the 7th. What you want to try to do is get an even power down there so that you can take everything out of the denominator. So you don't leave anything in the denominator. So I'm going to rewrite this as an x to the 7th times an x to the 1st. That would give me an x to the 8th in the bottom. But if I multiply the denominator by x, I got to multiply the numerator by x. Because what's x divided by x? Anything divided by itself is 1. Okay, so now simplify. Okay, and there's different ways to write this. I could write y to the 2nd times y to the 2nd times y to the 2nd. You do the method that works. On the bottom, this would be x to the 8th. So x to the 8th. Okay, and then out of this I could take out y to the 4th. I still have a square root of y left, or square root of x. And out of the bottom, x to the 4th. And there's no, that's how you get rid of something in the denominator. Okay? If that would have been, let's say, an x to the 5th down there in the bottom, then you'd multiply by still an x to the 1st, because that'd give you an x to the 6th. You want to try to get an even index. And that's controlled by what that index is. Okay, let me give you one that's a different index. So I have the cube root of 2 divided by 9x, and that's all underneath the one radical. The cube root of 2, and it's all over 9x. What you look at is this, and you look at this. And you got to think about this a little bit. Nine is actually 3 squared, and I need it to be 3 cubed. So I need to take that 9 times 3. That'd make it 27. 27 is a perfect cube. The x to the 1st, I need to multiply that by x to the 2nd. Okay, so I really need to write this different. I need to write this so you can see what I'm doing. This is x to the 1st. I multiplied by 3x to the 2nd. So I have to multiply the top times 3x to the 2nd. Okay, so now I have 27 x to the 3rd in the denominator and 6x squared in the numerator. Okay, so out of this I can take out 3. Out of this I can take out an x. I have left the cube root is 6x squared on top. It's okay to have a radical on top. You just cannot have a radical in the bottom. You take out, so I'd have over 3x. Okay, so you're looking at this index, and you're looking at the denominator. What do I have to multiply that denominator by to make it a perfect cube? Yeah, 3 and then the x. Okay? Okay. Let's go one more. This one, we're going to go 5th root of 5 divided by 4a. You're looking at this index, and you're looking at the denominator. 4 is actually 2 squared. I need it to be 2 to the 5th. So what do I have to multiply it by?
3.
2 to the, so I'm multiplying by 8, or 2 cubed, right? So this, and you can do it, you can write it either way. I don't care if you write it 2 cubed or if you write it 8. And for the a, I have a to the first, and I need it to be a to the fifth, a to the fourth. So the 5, take it times 8, a to the fourth. So what I really have on the bottom, I have 32, a to the fifth, and 40, a to the fourth. Okay? Out of this, 32 is 2 to the fifth. So I can take out a 2. A to the fifth, and I'm taking the fifth root of it, so I can take out an a. I can't take anything out of the top. Fifth root of 40, a to the fourth. So you're really focusing in on the denominator. Okay? Kind of get the idea with those examples? Okay. A couple more on simplifying. Okay, they will ask you to simplify and multiply. So we're going to use that product. So if they have 5 and the cube root of 100, a squared, times the cube root of 10a. Now you could try to simplify, but there's no cube root of 100 and there's no cube root of 10. So on the product, okay, it's okay to multiply those back together. Okay, so then you should be able to say 100 times 10 would be 1,000. And a to the second times a to the first would be a to the third. Leave the 5 out front, and now simplify. Cube root of 1,000, 10. Cube root of a cubed, a. And when you take them out, you multiply them. So 5 times 10, 50, a. There's nothing left inside the radical on that one. Okay? Where you have to be careful on problems like that is don't let the author catch you back up on this one. Okay? If n is even, those two numbers have to be positive inside. You can't multiply by a non-negative, so don't let the author catch you on that one. Okay, last example. 7 times the cube root of 75, a to the fourth, times 3 and the cube root of 45, a to the second. Okay, it's odd. Okay, so it's okay to put them together. 7 times 3 would be 21. And I'm actually going to, instead of just multiplying them, I'm going to say it's 75 times 45 times a to the sixth.